Hey everyone, my name is Dr. Galatia Strong. I'm a physical therapist who got 100% on my NPTE, and this led me to found SPT with me, which is an NPTE prep platform. If you enjoy what you see and you're studying for the NPTE, check out our courses at sptwithme.com. Now for what you're actually here for, let's talk about what a motor unit is. A motor unit is a functional unit composed of a nerve and the number of muscle fibers it connects to. This is an image that maybe you've registered in your brain and you immediately connect this image with the idea of a motor unit. That's great. However, I will tell you that this image is an extremely simplified version of what a motor unit is. And what makes this image just not the best representation of what it really is the fact that it's showing one neuron coming from the anterior horn of the spinal cord, and it directly goes to the muscle fibers. Well, pretty much all of our nerves end up branching into multiple other nerves, right? So the fact that this shows just one tract is not very realistic. So what I'm going to do throughout this video is demonstrate so you can understand what a motor unit really is. And I'm going to use an example of how we come from the spinal cord and make our way down to the flexor pollicis longus muscle. Before we begin actually coming from the spinal cord and talking about the nerves, it's really important to realize what level we're at with respect to within a muscle. So in this image, you can see that we begin from the big skeletal muscle to where when we slice it in a cadaver, or just picture it in our heads, we dive deeper and we become a fascicle. Then within the fascicle, we have a bunch of muscle fibers. In this image, you can see that there's a nerve that innervates the muscle fiber. So when we're talking about the motor units, they are at the level of here, the muscle fiber. The muscle fiber, aka a myocyte. The reason it's known as a myocyte is because this is the muscle cell. A sarcomere is not the muscle cell. The myofibril is not the muscle cell. The muscle fiber is the cell. Time to start talking about the nerve that eventually makes its way to innervate the flexor pollicis longus muscle. Also, there's no reason that I chose this muscle. I just ended up choosing it. So we're going to start at the level of the cervical spine, C5 through T1, C5, C6, C7, etc. Sometimes it's C6 through T1, but all of them combined eventually will make the median nerve. So this is the median nerve made up of all those spinal segments combined. The median nerve is going to travel down the arm and eventually turn into multiple branches, including motor branches and sensory branches. The branch that I care to talk about with respect to a motor unit then is obviously going to be from a motor neuron. So we're talking about the motor branches. So the median nerve is eventually going to turn into the anterior interosseous nerve. It's a motor branch. You can see that the nerve is going to make its way down to the respective muscle that I talked about, the flexor pollicis longus muscle. Here is a more zoomed in version showing how the anterior interosseous nerve innervates the flexor pollicis longus muscle. What happens here is that the anterior interosseous nerve is then going to branch into a bunch of tiny branches that will attach and communicate with a bundle of muscle fibers. Not sarcomeres, not myofibrils, the muscle fibers. On a physiological scale, going back to the previous image that I showed, you see that the nerves are going to branch out. And then those branches are going to branch out. So one anterior interosseous nerve is going to branch out into a bunch of smaller nerves to attach to a certain number of muscle fibers. One muscle fiber gets only one little nerve branch. And you can see it in this image. The purple and the pink nerve branches do not overlap with the same muscle fibers. So this is an image, going back to the beginning, this is a summary of everything that we talked about. So I hope you can see why this image now is just an extremely simplified version of what really happens along the way from the spinal cord all the way down to the motor units. There's a lot of splitting into branches along the way. How many fibers are there within a motor unit? Of course, as always, our answer is it depends. But let me walk you through why it depends. If you take a look at the picture, I want you to imagine if there was just one motor unit. So take away the purple one and everything that the purple one innervates. So in your head, have it innervated with just the pink ones. So if I contract everything, all the muscle fibers will contract as well. If I have one motor unit, I cannot select just a few muscle fibers of that motor unit to contract. It's all or nothing. If I want to be able to contract, but maybe have a little bit more control on how I'm contracting a muscle, then I would probably need two motor units. So looking back at the picture, the purple one is now back in play. So let's say the pink motor unit contracts first, it's activated, while the purple one is now relaxed. So really only half of the muscle fibers are contracting. This is going to allow for my muscles to recruit with a bit more control versus just a powerful all muscle fibers at once movement. Now, with that being said, it should make sense that if I have a muscle that's designed for power, such as the quadriceps or the glute max, I probably have motor units that contain many muscle fibers versus a muscle that's designed to do more fine-tuned work and requires dexterity. In this case, I'll likely have a muscle or motor unit with fewer muscle fibers. An example would be the muscles of our hands. I don't need a forceful flexor pollicis longus. I want a flexor pollicis longus that contracts just enough for me to be able to use chopsticks or a pencil. I am not trying to break what I'm trying to hold. Every single muscle fiber is different, but to at least give a range, a muscle that is designed for dexterity probably, once again, has fewer muscle fibers in a motor unit. So it could have anywhere between as few as 10 to 100 fibers, while a muscle that is really just used for power doesn't require dexterity, and in this case, it can have anywhere between 500 and 1,000 muscle fibers. As physical therapists, we're always thinking about how do we implement what we learn. I will tell you, you cannot change the number of fibers within a motor unit. That is predetermined while we are in the womb, while we're growing up. When we are talking about motor units and its use, what can happen is that when you train, when you're exercising, you're strengthening, you're powerlifting, whatever it is, what happens is that the number of motor units that you recruit, that is going to increase, not the number of muscle fibers within the motor unit. So just understand, motor units do not increase in number of muscle fibers, but you can just increase the recruitment of the number of motor units themselves. If you enjoy material being taught this way, check out our courses at sptwithme.com when you're studying for the NPTE. Take a look at these references for more information.